to remove an electron from the isolated gaseous atom. For example, this is sodium. Okay, this is sodium atom, and it is going to have one electron in its outermost shells. And if it is solid, any metal, if it is solid, so first of all, we will convert it into, okay, first of all, if it is solid, we will convert it into the gas. So gas, and then this gas, then we have to apply the energy, and then this will be get converted into, okay, this, and plus one electron. Okay, so this is called ionization energy. Got it? This is called
Yes.
ionization energy. Okay. And similarly, if we have Cl2 chlorine gas, so first of all, we will break the bond. The bond dissociation energy will be required here. And then it will get converted into Cl atom. And then this Cl atom will be converted into gas. And okay, this is gas. And then ionization energy will be required to remove Cl, one positive and one electron. So the amount of energy that is being required to remove an isolated gaseous atom, we called it bond dissociation energy. Okay. Got it? That is
Yes.
So let's move further today. And we shall be discussing today the order of ionization energy in 3D and 4D groups. We have discussed this one. And this is directly proportional to the atomic size. Means if the atomic size is more, then we will say that the more and the less amount of energy will be required. So we can say that ionization energy is inversely proportional to atomic size that we have discussed. Okay, got it? So if the atomic size is more, then ionization energy will be less. Why? Can you tell me the reason? Can you tell me the reason for this one? Lena, are you there?
Oh, yes.
Can you tell me the reason why the ionization energy is less and here? If the atomic size is more, then ionization energy is less. Can you tell me? This is very simple. Why? Because you know that if the bigger in size, when the atom is bigger in size, if the atomic radius is keep on increasing, okay, then the outermost shell will become far away from the nucleus, and so more easily and less amount of energy will be required to remove the electrons. Okay, got it?
Yes.
Now let's move towards the next type of energy that is called electron gain enthalpy or electron affinity. This is important. Electron affinity, electron affinity, or we can say that gain enthalpy, electron gain enthalpy. Okay. So what I'm saying here that what is electron gain enthalpy means it is the amount of energy that is being released. Okay. Or we can say that that is being absorbed. You can, or it can be both, because this process can be both exothermic as well as endothermic. Mostly this process is exothermic in nature because we know that if an electron is away from the nucleus, you can say that if it is uh, that let's suppose this is the outermost shell of an atom, and we are just considering an electron which is not affected by the force of this nucleus, means this nucleus is not exerting any force on this electron. So we'll consider this one that this electron is going to have the maximum energy. Okay, are you getting my point? What I'm
Yes.
saying here, that an electron will have its maximum energy is zero. Personally, we have arbitrary chosen maximum energy an electron can have, and electron can have can have can have is zero, and it is arbitrary chosen. It is arbitrary chosen that we have chosen the maximum energy. So for example, if something maximum is zero, so the minimum of that one will be negative. Got it? For example, if the maximum of something is 0, so the minimum or the less than 0 is always negative. We consider this one. Okay, so for example, this is the maximum energy that an electron is going to have when it is not affected by any nucleus, when it is not in the contact or it is not experiencing any positive charge force. Okay, so this is free, or we can say that this electron is at infinite distance from the nucleus. Okay, where it is not exact, or where it is not affected by any positively charged nucleus force, or it is not experiencing any Z effect. Okay, got it? Got it?
Yes.
Now, if this electrons comes in the contact, and if an electron is revolving around the nucleus, okay, then it is going to have negative energy because it is in the, it is not going to have its maximum energy. So it will get, we will consider it as that it is having negative energy. Why? Because its energy is maximum when it is at infinite distance. So if it is orbiting any nucleus and it is under, if it is under the effect of any nucleus, then it is going to have negative energy. Negative energy. Okay. Now, suppose something we have zero, the maximum, and there is -5, -10. Okay, just I'm just explaining you this one. -15. So zero is maximum. So this is the energy when an electron is going to have maximum energy, or when it is not experiencing any positive charge under the influence of any nucleus. Okay, so it is at infinite distance. We can consider this one as it is at infinite distance. Okay, got it? Now, if it is orbiting, for example, this is an electron, like for example, this is a chlorine atom. Okay. Okay. So let, this is the outermost shell I'm drawing of chlorine. 1, 2, 3, 4, 5, 6, 7. And now it is going to gain an electron, which is not in the influence of this one. Now this electron wants to orbit this nucleus. This nucleus it wants to orbit, or it wants to attain the stable chlorine atom want to attain the stable electronic configuration of 288. Okay, it want to add an extra electron from outside, which is going to have, right now this is going to have maximum energy, maximum energy. Okay, that is zero. That is zero here. Now when it start orbiting this one, so it will have to lose, this electron has to lose its energy. If electrons comes here in the orbit, because it is not now it is orbiting the nucleus, and it is under the effect of this nucleus, so it is not going to have its maximum energy. So you know the something is zero. Now let's just imagine this is going to have -5 energy here. -5, -5. Okay, so what it will do, it will lose some energy because its maximum is this one. It is now having its maximum energy here. But when it start revolving around the nucleus, it is not going to have its maximum energy. So it will release its energy. Okay, something I am having, suppose I'm going to have 100 rupees note. Okay, and this is my maximum limit. Okay, that's I'm explaining you. This is my maximum limit. So if I want to have a 50 rupees in my balance, so I have to spend 50 from this one. Are you getting my point? Similarly, if an electron want to revolve around a nucleus, then its energy is not maximum during that time. So it has to release its energy, because it only can have maximum energy if it is going to have, uh, if it is not under the influence of any nucleus. Okay. Are you getting my point? So when electron is added, the energy is being released. Got it? Got it?
Yes.
Why? Because this is going to have the negative maximum energy already, and when it comes, when it is going to revolve around the nucleus, then during that time it is going to lose some energy so that it can orbit, because in the orbit electron don't have maximum energy. Okay, so it has to lose some energy. In the similar way, if I talk about this one, if this is an electron, okay, and this electron is having some negative energy. Why? Because it is not maximum, because it is under the influence of any nucleus. So if it wants to leave this shell, so when it leaves its shell, it will become maximum. Its energy will be maximum. It will be zero. So for example, here it is going to have 5. So it need +5, so that -5 + 5 will become 0. So whatever the energy it is going to have in its outermost shell, that amount of energy is being to, it need to gain, okay, to become 0. Because in the orbit, it is going to have minus energy always. So if it is, suppose it is going to have -50 joule energy of this orbit, then it will, when it is going to lose, so it will require a +50 joule of energy, so that it becomes 0. So +50 means energy will be added. So in the chemistry, whenever you are just going to have plus sign, so it means energy is given or energy is supplied. So plus positive sign of energy indicate endothermic process. Endothermic process. Okay, that energy is being added. And if it is going to have negative sign energy, then it will be exothermic process. Thermic process. Okay, are you getting my point? Are you getting
Yes.
my point? So in exothermic process, energy is being released. So that's why electron gain enthalpy is maybe, for example, here in some cases it can be mostly in most of the cases, if we just consider this one, that electron affinity or electron gain enthalpy is actually an exothermic process, because the electron is being added in this one, and when the electron is being added, so it is the electron which is going to have the maximum energy. It has to lose some energy to in order to orbit the nucleus. So during that time, what it need to do here is that it need to lose some energy. Okay, it need to lose some energy. Are you getting a point? So that's why when losing some energy means that the energy is being released, and this process is known as exothermic process. But in some cases, if I talk about in some cases, for example, if I talk about the noble gases are already having the almost stable electronic configuration 1 2 3 4 5 6 7 8, and if you want to add the extra electron to this one, so they will repel it. Okay, they will not required, because it is already stable. In the case of noble gases, okay, for example, argon, and if you want to add the electrons to the argon negative, then during that time you need to pay extra energy to it, because argon is already stable and will not try to lose its energy, or we can say it will not like to add any electron because it is already stable. So during that time, when we are just adding the electron uh, to the outermost shells of an noble gas, which is already having a stable electronic configurations. So if you add an electron to this one, this will be considered as endothermic process. So most of the cases, electron affinity or electron gain enthalpy is an exothermic process. But when you are adding this one, an electron, okay, but when you are adding an electron to the noble gases, then during that time, addition of electron to the noble gases is considered to be as endothermic process. Then you have to give the energy. Understood? Got
Yes.
it? So this process actually, what is this actually? So we can say electron affinity, electron affinity is is related to formation of anion or addition of electron. Okay, like half Cl2. When you add the electron to it, it will gives you chlorine gas. Okay, and then we will going to add one electron to it. In the gaseous forms, we are going to add this one. Okay, you understood?
Yes.
So for example, if we are having metals, and metal is in solid state, and if you are adding an electron to this one, let's suppose this is in gaseous state, this metal is in gaseous state, and you are just getting a metal ion in the gaseous state and plus one electron. So whatever this energy is being released here, this, let's suppose this energy is being released. Okay, so that amount of energy which is being required, this the same amount of energy will be required to remove to add this electron. So you can consider this one, that really energy is released during the formation of an ion. Ion means negatively charged. Okay, got it? And it is an exothermic
Yes.
process. So note it down. Note it down that addition of electron in an anion is always endothermic process. It is always an endothermic process. If you are adding an addition of electron to an anion, okay, anion means which is already a negatively charged species. Okay, so if you are adding to anion, which is already a negatively charged and you are adding extra electron to it, then it will be an endothermic process. Otherwise, it is an exothermic process. Otherwise, to an anion or noble gas and noble gas and noble gas. Noble gas is an endothermic process. Otherwise, we can say that otherwise addition of electron to an atom is always an exothermic process. Thermic process. In most of the cases, generally it is an exothermic process. Got it?
Yes.
Now you can understand this more betterly. For example, here, if you are having an oxygen atom in the gaseous form, and you are adding one electron to it. So here, to attain the stability, we can say that O will become O negative one in the gaseous form, and it will be considered as, we will consider it as negative. Okay. And here if we are just adding one extra electron, so this is an exothermic process. This is an exothermic thermic process. Okay, but if you are adding extra electron to this already, first of all, it is already going to have a stable electronic, no, it is not going to have a stable electronic configuration. If you are adding an extra electron to this one, then it will be considered as, because because work is done here. Okay, in order to add this electron to this outermost shell. Why? Because electron start repelling each other. So it is already having 1, 2, 3, 4, 5, 6, and you have added one extra electron to this one. Now, if you add an extra electron, so this electron pair will start repelling each other. So because of that, if you need to add electron to this outermost shell of this O negative, which is already a negatively charged, or we can say that it is an anion. So if you're adding an electron to an anion, which is already having a negatively charged, so when you add it, due to electron repulsion, we have to work done. We have to apply the energy so that this electron can revolve in the orbit of this one. Are you getting my point? Are you getting my
Yes.
point? So this will be say that here it will be considered as electron affinity or electron enthalpy. Electron gain enthalpy will be considered as positive for this one. Positive means energy is added. Endothermic process. Got it? Got it?
Yes.
But if you are adding, for example, here it is gas, and if you are adding two electron overall, so overall adding this one, we have to apply the energy. If you are adding two electrons to this one, so overall, if you add this one, electron addition energy will be positive. Means this is an endothermic process. Endothermic process means you have to, got it?
Yes.
So we have a question here. Have you noted this one?
Yes.
We have a question here. Which of the following very high electron affinity. Option A, B. Electron affinity means electron loving, we can consider that loves electron. Okay. Here we have their energies. HF enthalpy for this one is 10 electron volt. Here enthalpy of is 50 electron volt minus 20 electron volt minus 30 electron volt. Note it down. And tell me which one is the correct. Keep in mind that more the negative energy means the energy is being released. Okay. Tell me which one is correct. Negative energy means ectothermic. The energy is being released. This is
B.
B will be the correct answer. Okay. Next is here we have another question on the same topic. Here we have a question. Electron affinity 1 and electron affinity 2 of oxygen gas of oxygen 1 is respectively A is minus 10 electron volt and minus 20 electron volt, B plus 10 electron volt and plus 20 electron volt, C plus 20 electron volt and minus 10 electron volt, and D minus 10 electron volt and plus 20 electron volt. Done? Tell me which one is correct. Overall, this process is considered to be as exothermic process, okay? Tell me which is correct.
D.
Hmm? Which one is correct? D is
D.
correct, na? First of all, it is an, we can say that it is an exothermic process. So, first of all, the energy is being released, then we have to supply the energy. So positive for this one, we have written this one here, that when this ionization affinity 1 is, first of all, it is an exothermic process. When it is exothermic, it will be negative. Okay. And then it become O negative gas. Then we add extra electron to it. Then it become O minus 2 gas. And this will be considered as positive. So here overall, it is positive. So here 20 minus 10 will get plus 10. Okay. Got it?
Yeah.
Understood?
Yes.
Factor affecting the electron affinity. What are the factors that are affecting the electron affinity? Factor affecting the electron affinity. The electron affinity. So what are the factors Can you tell me the atomic size? Will it be directly proportional to the atomic size or inversely proportional? Tell me, if the atomic size increases, what is that force which is helping to gain the electron? It is nucleus force. Okay. Positively charged nucleus is present in the center. So if the size of the atom is keep on increasing, so we will say that less amount of energy will be required to gain the electron, or more energy will be required to gain the electron. So actually, electron is, if the atom is outermost shell is nearer to this one, okay, then more energy will be released because the electron is held by the nucleus. So if it is going to be a bigger size atom, the outermost shell will be away from the nucleus. It will be bigger in size. So if this electron needs to enter, so this nucleus will not be able to hold this one. Okay. So smaller the size, we will say that, okay, we will say that electron affinity will be inversely proportional to the atomic size. Means if the atomic size is more, then electron affinity means loving. We can say that the nucleus power of attracting the electron is will be less. Got it? Got it? You understood?
Yes.
Electron affinity, we also called it electron loving. Electron loving. So if I talk about this one is that electron affinity is inversely proportional to atomic size. Atomic size. Okay. And similarly, we know that if there is a screening effect, for example, if this is a nucleus and there is a innermost shell electron, there are a lot of innermost shell electrons. Okay. And if due to that innermost shell electron, this nucleus will not be visible, or this nucleus positive charge will not be visible to this one. So the power of attracting the electron will be less. So we can say that if the screening effect is more, then electron affinity will be less. Okay. So we can say another one is that electron affinity is also inversely proportional to screening effect. Screening effect. Got it?
Yes.
Got it? You understood? Next is positive charge. If there is positive charge, so more the affinity if the electron is fully filled. Okay. And similarly, if there is already half filled and fully filled electronic configuration, then electron affinity means the nature for, we can say that if suppose it in case of nitrogen, if I'm talking about, okay, nitrogen. So if nitrogen will not be more affinite as comparison to that of oxygen. Okay. Why? Because nitrogen is going to have electronic configuration 1s2, 2s2, and 2p3. So this is going to have half-filled electronic configuration. And if I'm talking about this one is 1s2, 2s2, 2p4. This is oxygen. Okay. This is oxygen. So it will affinate more, means it will like to gain electrons, okay, more easily as comparison to that of, rather it is going to, or moreover it is going to have a smaller size. So there can be so many other cases. Okay, understood? Got it?
Yes.
So we can say that if the electronic configuration, electron affinity decreases if there is already fully filled and half filled electronic configuration is there, and electron affinity increases if, suppose if I'm talking about 1s2, 2s2, 2p, 2p2. So in this case, it wants to attain the stable electronic configuration and want to have is 2s2, 1s2, 2s2, 2p3. So it will try to gain more electrons. Means it will, in order to attain the stability and in order to attain the half-fill stable electronic configuration, this is actually uh, carbon. Okay, and this is actually nitrogen. So nitrogen has more electron affinity as comparison to that of carbon. Why? Because carbon is going to have more affinity as comparison to that of nitrogen. Why? Because nitrogen is actually going to have already half-filled electron configuration, and carbon wants to have the half-filled electronic configuration, wants to have 2p3. 2p3. Okay, got it? Got it?
Yes.
So here we can say that half-filled. And moreover, so here we can write it that along a period, mainly, if I'm talking about this one, that lithium beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay. So this is going to have half-filled electronic configuration. This is going to have half-filled, and this is going to have fully filled. Okay. So these are generally going to have the stable electronic configuration. Now, if I talk about this one, that if I order of electron affinity. So if I talk about the electron affinity, we can see here that the fluorine will be more electronegative because fluorine is going to have a smaller size and it needs only wants to have the stable electronic configuration. Okay, because it is already going to have 1s2, 2s2, 2p5. So wants to have to have 2p6. Okay, 2p6. So it will have the means it will like to have an electron. So that's why it is considered to be as most electronegative element in the whole of the periodic table. Okay, fluorine. Then after fluorine, we have oxygen. Oxygen. And then we have carbon. Then we have carbon. Why? Because this is going to have 1s2, 2s2, 2p3. And it is going to have 1s2, 2s2, 2p2. So actually it wants to have 2p3 first. It is already half filled and it wants to have. So carbon is first. And then we have lithium. Okay, all of them. Then we have lithium. And then we have boron. Boron. And then we have nitrogen. And then we have beryllium. And then we have neon. So draw this one.
Done.
Similarly, along a group, if I called along a group, along a group, if I'm talking about along a group, that and then along the group, what is going to happen here is that as we go down the group, almost the size of the atom increases, and the size of the atom increases, then what is going to happen? The tendency to hold the electron will decreases, and moreover, the screening effect also increases. As we go down the group, screening effect also increases. So we can consider this one that as we go down the group, the size of the atom increases. So we can say that electron affinity, because the nucleus is going far away from the. So here we can say that atomic size is dominant. Atomic size is dominant. Means if it increases, then electron affinity. If electron size increases, then electron affinity decreases. It decreases. Got it?
Yes.
Now we need to note it down. One thing here is that this is important. You have to note it down that electron affinity of the same means I'm not talking about the third period. Okay. The electron affinity of some third period elements are more than the electron affinity of the second period elements. Okay. Means second period and third period. If I'm talking about to electron affinity, why? Just this is an important, very important. You need to understood here that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay. And this is the second group elements. And the third period is sodium, magnesium, aluminium, silicon. Okay. And here we have nitrogen. After the nitrogen, we have phosphorus, then sulfur, then chlorine. So you need to understood that as we are going down the group, okay, the atomic size increases, but due to small size of fluorine, like I'm just talking about the small size of fluorine. So in this case, fluorine will not, electron affinity means to have the electron permanently. Okay, we will going to study the two things, electron affinity and electronegativity. Both the things you need to understand more appropriately. Okay, so what I'm saying here that in case of fluorine, if I'm just making the shell of fluorine, the fluorine atom is very small in size. This is the 2 shell and this is the 7. 1, 2, 3, 4, 5, 6, 7. And since the size of the fluorine outermost shell is small, so if we are adding the one electron permanently to it, so it will resist. Why? Because of the small size of fluorine atom. This is very important. You need to understand here. Very, very important case. Why? Because fluorine, otherwise the size of the chlorine atom is increases. So size, if the size of the atom increases, then what is going to happen? Simply, that if the size of the atom increases, the outermost shell will go away from the nucleus and will not going to hold the electron permanently. Okay. It will not going to hold the electrons. So we can consider this one that nucleus is going to, if the nucleus is far away from the outermost shell electron, then in that case, the positively charged nucleus will be away from this one. Are you getting? It will
Yes.
be away from this one, so it will not be tightly bonded, or it will not be holding this one. But in case of chlorine, if I'm talking about chlorine being the third period, and it is going to have the more shell, or we can say the size of the chlorine atom is bigger than the fluorine atom, but still the tendency to hold electron of chlorine, or we can say that electron affinity of chlorine is more as comparison to that of fluorine. Affinity means to permanently hold the electron permanently. Okay. So if I'm talking about this one, that fluorine is going to have a small size, and it is going to have 7 electron, and chlorine is also going to have 7 electron here, but the tendency to hold an extra electron is in chlorine permanently is more, or we can say that electron affinity of chlorine is more as comparison to that of fluorine. The reason behind this is that due to small size of this one, the inter-electronic repulsion will be more. The inter-electronic repulsion will be more in fluorine atom. Okay. Why? If you add an extra electron to this one, so they will repel it. Why? Because of the small size. So being a small size, here the electron affinity of chlorine is more as comparison to that of fluorine. Why? Because in chlorine atom, there is an extra shell, and due to that shell, the size of the atom is bigger, and the electrons are far, far away from each other. So inter-electronic repulsion is less. Inter-electronic repulsion is less. You understood this one?
Yes.
So if I wrote this one, that here, the very, very important part of this one, that what is the order of this one? So first of all, if I talk about this one, that if I'm writing this is nitrogen, and then carbon, then oxygen, and then fluorine, and then we have phosphorus, okay, then silicon, then sulfur, and then chlorine, okay. So nitrogen here is the least, and then phosphorus, then carbon, and then silicon, and then oxygen, and then sulfur, and then we have this fluorine, and then we have chlorine, or we can write it like this way. Okay. So how can we can write this like this way also, that here we have nitrogen greater than phosphorus, then silicon, sorry, nitrogen, then phosphorus, then carbon, then silicon, then oxygen, then sulfur, then fluorine, and then chlorine. So we can consider this one, that chlorine is the most electronegative element, maximum. Okay, maximum electron affinity. Got it? Note it down, please
Yes.
copy this one. This is an important portion. So many question is being asked for this one.
Done.
So if I ask you, what is the reason that, what is the cause? Question, if the question comes in examination, what is the cause? What is the cause? Cause that, what is the cause that chlorine atom is having more electron affinity, electron affinity, affinity than fluorine. Okay. The reason is due to small size, due to small size of fluorine, or we can say that due to small size of fluorine and high electron density and high electron density, there is it is electron repulsion. There is more electron electron repulsion in fluorine than chlorine. Understood? Note it down, please.
Done.
Done?
Yes.
Okay. So if I have a question here, exothermic. A. More the electron affinity, more will be the exothermic process. Okay. Tell me.
C.
C. Yes, C is the correct answer. Okay, next question. Do this one. Tell me which is the correct answer.
B.
Tell. Hmm? So first note it
B.
down. What is the electronic configuration? Which is that this element? This is carbon. This one is silicon. This one is,
Oxygen.
this one is oxygen. This one, tell me, 10 and 4. No, this one is actually sulfur. Okay. And this one is silicon. So tell me which is going to have the most electron affinity. So we have like this chlorine, then fluorine. Okay. Then we have sulfur, then oxygen. And then we have like this. Okay. So fluorine is not there. The sulfur is going to have sulfur. So B is the correct option or C is the correct option? Tell me. B is the
B.
correct option. Got it? Sulfur is going to have the most electron affinity. Sulfur. Got it?
Yes.
So this we have done, and so many questions is being asked in the examination for this table. Okay, anomalous behavior of two and third table. Okay, so let's have one more question on this topic. 10 electron volt energy is released. Energy is released when isolated fluorine atom is converted into F negative. Then magnitude of energy released is equal to, here it is saying that 10 electron energy is released when isolated fluorine atom is converted into F negative. Okay. Then the magnitude of energy release is equal to, first of all, ionization energy of fluorine minus gas, A option. Second option is electron affinity of fluorine gas, ionization energy of C is electron ionization energy or electron affinity of D is ionization energy. Tell me, which one is the correct answer? Tell me.
A.
Hmm? Which one is correct? Tell me.
A.
C. Actually, you know that energy is released when, this is fluorine atom, okay? And you are adding electron to it. So that is F, okay? If it is getting converted into F negative ion, okay? Now, if you remove an electron, so here the energy is being released, okay? Now, if you remove an electron from this one and making it fluorine atom, so that will, what amount of energy will be required? This is called ionization energy. So ionization energy. So whatever the energy is being required here, this is the energy release is known as electron gain enthalpy. Gain enthalpy. Here, if we are having F negative and we are just removing an electron, then we have to supply that amount of energy. This is known as ionization energy. So D will be the correct answer. Got it?
Yes.
Got it? Okay. Now the next topic is electronegativity. These two terms, electron affinity and electron negativity, is almost similar, but there is some differences here. Okay, we need to understand this one. Electron negativity. Electron negativity, we consider it as Vn, En capital N. Okay. So what is this actually? This is actually the tendency of an atom to attract the electron pair, which is already bounded towards itself. Okay, for example, this is hydrogen atom, this is chlorine atoms, and they are the electron cloud. So chlorine being more electronegative will attract this bonded pair of electron towards itself. So actually this seems that this is not at the center. If this is the center of the line, which is the two atoms are here, but actually this electron of hydrogen will also shift towards the hydrogen. So we'll consider here this thing that this shifting of electrons or the bonded pair of electron towards the more electronegative element is considered to be its electronegativity. So the more electronegativity an element is, or more electronegative an element is, the shifting of bonded pair of electron toward itself will be more. Are you getting my point? What I'm saying to you? Are you
Yes.
getting? Shifting of bonded pair of electrons. This is the bonded pair of electron. This is chlorine. This is hydrogen. So this bonded pair of electron will shift more closer towards the chlorine. The shifting of bonded pair of electron towards the chlorine is considered to be as electron negativity. You understood?
Yes.
Understood? Tendency of an atom to attract electron pair of bond towards itself is known as electronegativity. Okay. So for example, if this is A and this is B element and these are the bonded pair of electron. So if this electron gets shifted towards the A, if A is more electronegative, then this pair of electron will be shifted towards A. So this is going to have slightly negative charge and this is going to have slightly positive charge because the electron is shifted towards it. So it will become more electronegative, and due to that one, if A is more electronegative, then the bonded pair of electron will shift toward this A so that it will acquire a slightly negative charge. Why? Because the electron is negatively charged and it will shifted towards the A, so it will going to have or acquire the negative charge. Are you getting my point? What I'm saying to you? And
Yes.
if the bonded pair of electron is shifted towards B, if it is shifted towards B, if B is more electronegative, then it is going to have electronegative, means slightly negative charge, and this and going to have slightly positive. And this property, okay, we can say it is a property of an atom to attract the bonded pair of electrons, okay? And actually, electronegativity is a unitless quantity, okay? It is a unitless quantity. So we can say that it is a property of bonded atom to attract the bonded of pair of electron, electronegativity. So we can write here that it is a property of bonded atom bonded atom, and is unitless quantity. Unitless quantity. You're getting this one?
Yes.
So we have a table here, and how we need to calculate this one, we need to understand this one. So have you noted?
Yes.
Okay. Here we have, let's suppose if we have hydrogen here and lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Just a minute. Just a minute. Battery of my laptop is not working. So if I'm talking about this one, this is lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay. Then fluorine. And then we have nitrogen. Sorry. After fluorine, we have sodium. Sodium, magnesium, okay, aluminium, silicon. Then below the nitrogen, we have phosphorus, sulfur, chlorine. Okay. And then we have bromine. And then we finally have iodine. So here we have the values 0 0.1, 1.5, 2, 2.5, then 3.0, then 3.5. Okay. And then we have 4.0. Are you getting? And
Yes.
similarly, here we have for the sodium is 0 0.9, 1.2, 1.3. Okay. So not 1.3, it is 1.5. Then 1.8, then 2.1. Okay. Then 2.5 and then 3.0. And here we have 2.8 and there we have 2.5. Okay. Note it down.
Done.
Just a minute. My laptop charger is creating problem. So there are so many ways, okay, that is being required to measure this one. The most famous scale is known as Pauling scale. Okay, Pauling scale is used to actually find out the electronegativity of an element, and it is okay. Have you noted this one?
Yes.
So this is the most means how we can calculate. We have just calculated this electronegativity, and there can be so many scales. The first scale is that the Pauling scale. It is most famous scale. So we are just going to study this one, Pauling scale. Pauling scale. How we can calculation of electronegativity. Calculation of electronegativity. Negativity. Okay. So here we have Pauling scale. Electronegativity is equals to ionization energy plus electron affinity divided by 2 into 2.8. This is the Pauling scale. Okay, where you need to keep in mind that both ionization energy and electron affinity are calculated in electron volt. Got it? Done?
Yes.
So the question comes, just a minute. So if the question comes in your examinations, there can be so many types of questions. And generally, there are so many ways that that is being used. Generally, okay, Millikan scale is also there, which is being used to calculate the electronegativity. So let's have the Millikan scale also. According to the Millikan scale, Millikan, sorry, Millikan scale, Millikan scale, and what is the value of this Millikan scale actually? So Millikan scale is the generally ionization energy plus electron affinity divided by 2. This is Millikan scale. Okay, got it? So we can
Yes.
here relationship between, or we can say here that Pauling scale, this is the Pauling scale. Okay, so here we can say that if I took about this one, so we can write it Pauling scale is equals to Millikan scale divided by 2. Millikan scale divided by 2. Okay, divided by 2.8, sorry. Noted, noted fast. Done? Noted?
Yes.
So what are the factors that affect actually? So let's have a question first of all on this one, and then we shall be moving this one. Question here is electronegativity of an element according to Mulliken. Mulliken is 5.6, and an electron negativity, then electronegativity of the element according to Pauling scale is, tell me what's the answer.
2.
2. Yes, you're correct. The Pauling scale is equals to Millikan 5.6 upon 2.8. You got it, you will get 2. Good. Now factor affecting electronegativity. Factor affecting electron negativity. So what are the factors that are affecting the electron negativity? So first of all, there is atomic size. Atomic size, if the atomic size is, this is same. If the atomic size is more, then the nucleus will be far away. So the tendency to attract the bonded pair of electron will be less. So we can say that electronegativity is inversely proportional to atomic size. Atomic size. Okay. Do you understand the difference between the electronegativity and electron affinity? Electron affinity means that affinity means means we can say that electron loving in nature. If an element is electron loving in nature, so it must have the electron permanently in its outermost shell. So for holding the permanently an electron, the size of the atoms also matter, and also the electronic repulsion also matter. And what is we are just studying in the electronegativity is just to attract the bonded pair of electron. No, we are not just going to hold the electron permanently. We are just only attracting the bonded pair of electrons. Okay. Are you getting my point?
Yes.
So next is Z effect, the nuclear force, Z effect. The Z effect is more. So we can say that electron negativity will be more. So electron negativity is directly proportional to Z effect. Okay. Noted this one?
Yes.
If so, if I talk about this one, that the more the positive charge, electron negativity is directly proportional to positive charge. Positive charge. Okay. So if we have Cl plus ion, we have another Cl, we have Cl3 plus, and we have Cl plus 5. So in this case, we'll get that Cl5 will be going to have the more electronic affinity, then Cl3 positive, then Cl minus, sorry, Cl plus, and then finally Cl. Okay, got it? Order of electronegativity. Got it?
Yes.
So next one is percentage of S character. If the S character is more, we can say that percentage, 4 point is percentage S character. S character. So if I talk about number of pi bond, it also affect on the number of on this one. Okay, percentage S character is simple that in sp3 hybridization we have 25% S character. S character. Okay. Okay. And in sp2 hybridization we're going to have why because s then p. So 75% is space is opened by this one, and 25% is by this one. We have only sp2, so one s and p. So we have just 3 part of 100, so this will be 33%. 33% character. Okay, s character. S character. Okay. Then we have sp only, then it would be, tell me, then it would be, tell me.
50.
50%
50.
S character. Okay. So we can say that electronegativity is directly proportional to S character. So order of electronegativity, we can say that Sp will be more electronegative element as comparison to sp2 than sp3. Got it? Order
Yes.
of electronegativity. Now, if I talk about the periodicity in the periodic table, periodicity of electron negativity in a period. Got it? In a group, if the atomic size increases, then we know that atomic size increases, then electronegativity will decreases. Okay. Here, as we move from left to right, the atomic size decreases, so Z effect will increases. Z effect increases, will say that electronegativity will increases. Okay. Got it? Got it? Have you
Yes.
noted this one?
Yes.
Next is, here we need to keep in mind that in the boron family, we have this one. As we know, down the group, the electron affinity should decreases, but actually due to decrease in boron family, we if I just ask this one that atomic size will increases as we go down the group, and so the electron affinity should decrease. So this must have the highest electron affinity, sorry, electronegativity, then this one, then this one, then this one. But actually, this is not true. We have boron, then we have tellurium, then we have indium, then we have gallium, and then we have aluminium. Okay. And why it is so? We'll discuss this one. Okay, so this you have to note it down.